Nonlinear systems. Matrices probably not going to be your use here with nonlinear systems. With matrices, we were dealing with more linear systems and planar systems, and get into 3D there. But with nonlinear systems, what we're talking about taking is problems that may mix it up. You may have a linear equation in there like this one. 3x minus y is equal to -2, and it be paired in a system of equations with 2x squared minus y is equal to 0. And we're asked to solve that system of equations. So what we're looking for here really, if we think about it graphically, is where are 2x squared minus y and 3x minus y equals -2? Where are they crossing on the coordinate plane, technically, is what we're looking for. So that can be pretty daunting to find if you try to do it by graphing, because you're looking for where one's a parabola shape, one's a straight line. They're going to cross somewhere. It's kind of difficult to guess where that's going to happen. So algebraically is how you want to do this. So we're going to solve these with algebra out of that. And there's a couple of different ways to do that. With this one, I think about ways that I solve regular systems, like the linear systems, substitution and elimination. Those are the methods that you're going to want to use here. Like I said, matrices are of no use with this stuff. You've got to use the old way of doing things with either substitution or elimination. This one can work either way. I see elimination quicker than I do substitution, just because I like elimination better. If I were to look at that and say, okay, I'm going to do elimination, what variable would be the easiest to get rid of? The y's, because they're the same degree. You got y to the first power and y to the first power. No way I could get rid of x's there, because I got an x and an x squared. They're not the same degree. So I'm going to get rid of y's. And I'm just going to multiply the top one by -1 and change that problem to -3x plus y equals +2. And then I'm going to have 2x squared minus y is equal to 0. And then when I add those two equations together, the y's cancel out. I get 2x squared minus 3x is equal to 2, which is a quadratic equation. And if I'm going to solve a quadratic equation, what do I have to get it equal to? 0. So let's get that equal to 0. And then I have all of the options of how to solve a quadratic. We could factor it if it will factor. We could use quadratic formula to get the answers, whether it factors or not. Doesn't matter there. This one I think will factor. If I just quickly try 2 times -2 is -4. Is there anything that multiplies to be -4 and has to be -3? Yeah, -4 and 1. So I'm going to factor that one, because it will, and I'm a little faster at that than I am quadratic formula. So -4 and 1. So you would replace the 3x with the -4x and the plus 1x, and then group that to get 2x, x minus 2, plus 1, x minus 2. So my factors are 2x plus 1 and x minus 2. Set each of those equal to 0. And solve for x. -1/2, +2. Got 2 x values, so I should be finding multiple y values, 2 y values that go with that, right? So I can go back up here to my equations and pick one to plug into with each of those x values. I'm going to plug into the first one, so I don't have to deal with the squared and all that stuff. So 3 times 2 minus y equals -2. So I'm plugging in the +2, trying to find the y value that goes with that. So that'd be 6 minus y, -2, subtract 6, negative y is equal to -8. That means y is equal to 8. So I get this ordered pair, 2, 8. So solutions, here we'll just spot. 2, 8 is a solution. Then I would go up there and I'd plug in 3 times -1/2 minus y is equal to -2. Got to deal with fractions here a little bit. That's okay. We're big boys and girls. We can deal with fractions. Plus 3/2. -y is equal to 1/2. So y would be equal to -1/2. So we have -1/2. Wait, hold on. That'd be -1/2, +1/2. Sign. We get two solutions to this. And if you think about it, if you had a quadratic, that's the graph similar to that, and a linear equation, how many places do they cross? 2. That's the idea of what the graph is doing. But we're finding those places without.
Were there always been two solutions?
If you're dealing with a linear and a quadratic, depends on, we're gonna have some that are not just, it may be 2 quadratics, and there could be 2 solutions to that. It could be, much larger. There may be more than 2 solutions. The thing with it's not like a linear system where we had only the options of one solution, infinitely many, or no solutions. It's not going to be that. It's not that straightforward with the nonlinear systems. So there won't always be 2 solutions. So I can't say it's always that. If it's a quadratic and a linear, then yes, it is always 2 solutions, but it's not necessarily in all cases. It'll be 2 solutions. So let's look at example B. Give you an example of when it's not 2 solutions. Say we had x squared plus y squared equal to 13, and x squared minus y is equal to 7. Can we cancel the x squareds? Can I cancel the y's? You gotta look for things that are the same, like same degree. So this is where it's a little different than linear systems. We're not looking for opposite signs in front. We're looking for, okay, which ones are the same kind of term. So we've got an x squared on the top and an x squared on the bottom. So those are the same degree. So I would be able to cancel those with elimination if I wanted to. On the y's, I've got a y squared on the top one, but not a y squared on the bottom one. So those are not going to be able to cancel each other out. So if we're looking to do elimination, which is what I tend to look to do quite a bit, the x squareds would be possible. And I would probably multiply the second one by -1 to make that happen. That way I don't end up with a negative number when I add these together. And the top one's not changing. So when I add those two together, the x squareds are going to cancel out, and I get y squared plus y is equal to 6. And then that's a quadratic again. So I got to solve it like a quadratic. Y squared plus y minus 6 is equal to 0. I think that factors 3 and -2. So y plus 3, y minus 2. Y plus 3 equals 0. Y minus 2 equals 0. -3, 2. Those are my y values. I want to go back and find my x values that go with those, okay?
You just go back up and plug it in.
You can go back up there and plug them in. Does it matter which one I plug into? Technically, no, because the degree of the x is the same in both of them. So I'm going to just go to the second one because it seems smaller and easier. Don't have to square the y's and all that junk to get there. So I got x squared minus -3 equals 7. So that's x squared plus 3 equals 7. When I can solve that by square roots, which is a pretty good way. X squared is equal to 4. Yeah, so x is equal to plus and minus 2. So I get two ordered pairs out of the one y value. I get, my solutions. I'm going to list those over here. I get -3, +2, and -3, -2. Yeah, they should be the other way around. Sorry. X is first. 2, -3, -2, -3. Sorry. And then we got to do the same thing for the y equals +2. Plug that in. X squared minus 2 equals 7. X squared is equal to 9. So x is plus or minus 3. 3, +2, -3, +2. So with that one, we had 4 solutions to that. So the first equation is a circle. You may not know that, but it is. It's a circle. The second one's a quadratic. So you end up with the graph, what's going on in the background that really doesn't necessarily matter. You got a circle and then a quadratic doing like that. And, there's 4 places where it's crossing. That's what's happening on a graph. That would be very difficult to get exactly on the graph that way. It's very difficult to graph a circle on your graphing calculator to get it to do, not because you got to solve for y. So you got a positive side and a negative side of y because you take square root to get there. So it's very difficult to graph. Because that's the y value. +3.
I'm sorry, I'm looking at the wrong problem.
And then -3 too. And then the negative, this is the y value of -3, so that was where the plus and minus 2 was.
Yeah, I was looking at the wrong problem.
I got confused. I'll go to. No big deal. All right. Let's look at this one. X squared minus y squared equals 4. And then y equals x squared. That's our system.
Wouldn't you get X squared on the other side and you get the other?
What do you mean?
I subtract X squared.
I could also do substitution there and get the same thing to happen, right? If it says y is equal to x squared, I could plug in x squared where y is and work that out. But I like what y'all are doing. That's good. So that'd be -x squared plus y equals 0. Yeah, and then we don't have to deal with the y to the or x to the 4th power. That's good. So when I do that, the x squareds cancel each other out with elimination. I got -y squared plus y is equal to +4. I'm going to flip that to this. Why is that legal? Because I changed all the signs. That way I don't have a -a. It doesn't really change the answers to that at all. It just changes the numbers when I do my quadratic formula. Because that won't factor, right? So I'm going to do my discriminant. What's going on with my pen, but it gets stuck every now and then. I don't know what to do about it either. So negative b, or b squared, so negative 1 squared minus 4 times 1 times 4. So I end up with 1 minus 16, which is negative 15. What kind of answers does that have? If the discriminant is a negative number in quadratic formula, that means the answers are real or complex? Complex. That means there's going to be an I involved. So what that tells us is there are no real solutions to that. Okay? And we're looking at a system of equations. We're not looking at, we're looking for where it's crossing on the coordinate plane. Do imaginary solutions show up on the coordinate plane? No, they're not there. So no real solution. So this one can stop right there. Because that discriminant on the quadratic formula tells us it's negative, so that means there's not going to be any real solutions out of that. That would be a good thing to keep in mind. Let's look at this one. Let's say we had x squared plus x plus y squared minus 3y plus 2 equals 0. Ooh. Impressive problem. X plus 1 plus y squared minus y over x equals 0. That's right. Pretty ugly looking. Definitely not a linear system, obviously. We got x squared and y squared in the first one. The bottom one right now has only a y squared in it, but it's got a fraction in it. How can I get rid of that fraction? Yeah, if I multiplied everybody by the denominator, it would clear out that fraction, wouldn't it? And if I do the whole equation that way, it's legal. Because it's just like multiplying by a number. So I'm going to multiply that whole thing by x. And that's going to give me x squared plus x plus y squared minus y equals 0. So that's a lot better looking, I guess, than the original one was. It doesn't have the... All right, well, so let's see what will cancel out. So I'm going to... Well, nothing, how can we cancel that out? I would have to change the signs of one of them, right? So if I multiplied, let's just do this one by negative 1. That would change all the signs. And then stuff starts canceling. So the x squareds would cancel out, the x's would cancel out, the y squareds would cancel out. I'd end up with negative 2y plus 2 equals 0. And that's a pretty easy one to solve. I like that. Yeah, y is equal, not negative 1, but positive 1. Because when you move that 2 over, it's negative, and then divide by negative 2, so it's positive 1. So we get y is positive 1. Now we just need to find the x's that go with that. Okay. So I'm going to go back to the first one. X squared plus x plus 1 squared minus 3 times 1 plus 2 equals 0. And work that out. That's going to be x squared plus x. 1 minus 3 is negative 2 plus 2 is 0. So it's 0. So that we get that. How do we solve that? Is it a trinomial? We can't do the x. But we can have a GCF of an x. That's what we're saying there. And we get x is equal to negative 1 and x is equal to 0. Which one of those gets thrown out?
The negative.
Why the 0? What is the weird part about the original problem? Yeah, and what's the only number we can't divide by?
0.
0. So that's why we're going to throw that out. Because in this original problem, that guy right there, x being in the denominator, tells us x can't be 0 for this system of equations. It's not going to happen. It's a restriction on the domain is what it is for that particular problem. So that's why we're going to throw that out. So the only solution we're going to have for this one would be -1. Yeah, 1. So that big ugly system of equations only had one solution. All right, let's look at yeah, we got 10 minutes. Maybe we can squeeze this one in. Example E. All right. 3xy minus 2y squared equals -2. And then 9x squared plus 4y squared equals 10.
That's probably multiply the top by 2. You get the y squared is 10 squared.
Okay, so if I multiply the top one by 2, I like where you're going. That's a good idea. That's going to give us 6xy minus 4y squared equals -4. And then this one's staying the same, 9x squared plus 4y squared is equal to 10. When I add those two together, yes, the y squareds cancel out. I get this 9x squared plus 6xy equals 6. Huh. That's not easy quadratic like it's been being.
No.
Oh man. So we got something that's not easy quadratic like what we had.
Okay. Probably right.
Okay. It's kind of like, y'all remember Sesame Street? There was a song on there, one of these things, it's not like the others. You know, one of these things just doesn't belong. What doesn't belong up there? The y. If it was just an x, then things would be better. We could do quadratic formula and we'd be done. That's great. But y's there. Can we get y by itself? I think we can. I think if we move the 9x squared, that's going to give us 6xy is equal to -9x squared plus 6. And then divide by not just 6, but 6x. And that's going to get y by itself. And now I can reduce that a little bit. That'd be -3/2 x. And then plus 1/x. Okay. And then we've got to put in this stipulation that x cannot be what? 0. Because we divided by x. So we've got this stipulation here that x can't be 0 out of that. So we found y to be something weird like that. Now, here's what we can do with that. We've got an equation that if we go up here to the original, if I were to replace y in maybe this problem with that -3/2x plus 1/x, I would only have x's in that problem, right? I could go there as well, but then I end up having to multiply by x, and maybe this one's a little simpler because it's just one piece that we're plugging into. There, we would have to plug in 2 different places and do a little bit more work. So that's why I'm going here. No other real reason other than it's less work. So let's do that. Let's replace the y with what y is equal to. Yeah, and it's squared. All right, so square that first. Yeah, that's not fun. So that we're going to have to do the little FOIL method here. So that'd be 9 over 4 x squared minus 3 over 2, and then minus another 3 over 2 plus 1 over x squared. 3 over 2, negative 3 over 2x times 1 over x. The x's cancel out. So now we got this. I'm going to simplify there. I got 9 over 4 x squared minus, that'd be negative 6 over 2, which would be 3, right? So I'm going to put 1 over x squared. 3. 10. Well, that's not much prettier. Let's distribute the 4, see if it gets better.
36.
Which is 9x squared plus 4 over x squared minus 12 is equal to 10. That looks a little better because now I've got something I can simplify. Put those two together, right? That's 18x squared plus 4 over x squared. And I'm going to move this 12 over there with the 10 because it's a like term with the 10, right? Equal to 22.
Need that x squared on the top.
Okay. Okay, yeah. Similar to the previous example, we got rid of the x on the bottom by multiplying the whole thing by x, right? So here we got an x squared on the bottom. To get rid of that, we could multiply the whole thing by x squared. So let's do that. This is really as tough as it gets, guys. This is a tough problem. And now we've ended up with a polynomial that doesn't have any fractions in it. It's only got x's in it, and it's x to the 4th power and an x to the 2nd power, and I can move that and get it equal to 0. And what can I do with that? Well, they're all even, right? Divide them all by 2. And I got to think, okay, it's a polynomial. How can I solve it? Got a lot of different ways. One of those ways would be synthetic division with the P over Q stuff. It's a trinomial, so I'm thinking maybe it factors. With the x, multiply to be 18, add to be negative 11, negative 9, and negative 2. What do you know? It factors to be, so we got 9x to the 4th minus 9x squared minus 2x squared plus 2. That's beautiful because that's 9x squared. And that'd be x squared minus 1 minus 2. That's x squared minus 1, which is even better because now the factors are 9x squared minus 2 and x squared minus 1. What do I know about x squared minus 1? It actually factors itself, right? To x plus 1 and x minus 1 because we've done quadratics in here. But 9x squared minus 2 doesn't factor, so I'm going to have to use some other method to solve it. But that's easy. X plus 1 equals 0. X minus 1 equals 0. So x equals 1 or negative 1 and x equals positive 1. And then this one, you get 9x squared minus 2 equals 0. And you get, x squared is equal to 2/9. And you take the square root of that. And you get not a beautiful number, but it does work out a little bit nice. Plus or minus radical 2 over 3. Because the square root of 2, we don't know, but the square root of 9, we do. It's 3. So that's where that's coming from. So those are her x values. We got 1, 2, 3, 4 of them. Now the fun part, get y for all 4 of those x values, which is, this is the short part now. So we've got the x values, plug those in to that equation that we made up here earlier that had y equals something. Oh, hey, there's y equals. All I got to do is use that, and I can work this out. So y equals negative 3 over 2 x plus 1 over x. None of those x values are 0. That may be what's wrong with my pen. Fill it down. So we don't have to worry about canceling any of those out. So if we plugged all those in, we would get ordered pairs. 1, negative 1/2, negative 1, positive 1/2, square root of 2 over 3. Then square root of 2 is the answer on that one. And then negative square root of 2. And then negative square root of 2. Trust me on that, that's what those are. If you plug those in, you're going to get those. On tomorrow's workday, page 910, 5 through 53. All right. Okay. We squeezed it in there. Good job, guys. Yeah, it did.